So I know that a lot of you are familiar with this particular model where we had all these people that were healthy. So if you could see my screen, all the people that are red or orange, they're all healthy people. We have one sick green person right here, and of course, you have a sick person, as we know now. If you have one sick person, they can affect up to they can affect a lot of people. Well, I'm going to run this simulation, and then after a while, we're going to see some of the healthy people get sick, and then some of the sick people are actually going to recover, and they'll turn a weird shade of blue. So what I'm going to ask that you do is after I run the simulation for a while, we're going to have a mixture of recovered people, sick people, and healthy people. I'm going to ask you some probability questions about that. Okay. So right now, what I want you to do is just watch the simulation real quick. I'll run it just a little bit so we can get an idea what's going on. Okay. So I ran the simulation, and we see that we do have healthy people, we have sick people, and we have people who have recovered. They're the blue people. All right. So what I want to do is I want to give you some time, and you're going to get about, I don't know, because it's going to take some counting, and I know some people might have a hard time counting these. You'll have to recount some of the times. What I'd like you to do is count, or I'm sorry, find the probability that you would pick somebody out of this group and they would be healthy. Janelle, just real quick, go ahead and mute yourself. What kind of a number is a probability question?
A fraction.
Yes, ma'am. Thank you. So look, we're already going to give you a hint that the answer is going to be a fraction. All right. Now I did see Mia on here. Mia, what's one thing you're going to have to count to find the probability of the healthy people?
And all the people?
Very good. So check this out. Mia says we're going to have to count all the people on here. The sick, the recovered, and the healthy. So we need the total number of people. Isaac, unmute yourself and tell me, where would that go, in the numerator or the denominator, for the total people? What do you think? So Mia says we're going to count the total number of people, but where does the total number of people go? Either in the numerator or the denominator? What do you think?
The denominator.
It's going to go in the denominator. So look, we're already telling you, your total is going to go in your denominator. So, last question, and I'm going to see, I know Dorian was here. Dorian, what do you think? What do you think we're going to put in the numerator?
The healthy people.
The healthy people. So, ladies and gentlemen, go ahead, take the next 3 minutes, and go ahead and find the number of healthy people and put it over the number of total people. Okay, 3 minutes, go for it. It's been a little bit more than 3 minutes. How many total people did y'all count?
13.
46.
Total people.
I got
Wait, we have to count all of them.
127.
128.
Okay, I get here.
Oh, 127.
127, 128. Mr. Nando, did you get a number?
I got 128.
Okay.
Oh,
So look, especially with something this big, yo, I'm telling you, I had to count it. I don't know if you could see me on screen, but I had to count it a couple of times. It was tough for me to keep track, so I was trying to use a little tracker method without trying to disturb y'all. I got 128. So if you got 127, not bad, but you got 128. That's going to go in our denominator. All right. Now, how many healthy people are there?
13.
Okay, Isaac says 13.
13.
13? I agree. There are 13. So, ladies and gentlemen, the probability of somebody being being healthy after running this simulation is 13 over 128. The total number of healthy people over the total number of people we have.